Hi, so today we're going to be reviewing the semester 2 material for the Algebra 2 final, and we're just going to be going over some review problems. I have worked them all out or written them all out here just to avoid copying errors or any confusions, but I will be explaining each step in detail so you can follow along and write it down yourself as we go along. So let's get started with a Chapter 4 review problem that deals with completing the square. So the equation that we are given to start out with is 3x squared minus 12x plus 1 equals 0. So the first step that you're going to do here, you can see that I canceled out the 1's over here and subtracted a 1 over here. You're just going to subtract the 1 from both sides, leaving you with 3x squared plus 12x equals negative 1. Now the next step, you'd want to continue to get this x squared by itself, so divide both sides by 3, giving you negative 1/3 on the right side, and x squared minus 4x. Now there might be a little bit confusion about how you got why the 12x became negative 4x, but you have to remember to not only divide just this first 3x squared by 3, but also the 12x by 3. And 12 divided by 3 equals 4. So that is how you get that. Now the next step is to plug these terms into the equation b divided by 2, and the answer to that squared. So the b term in this is negative 4, so I just plugged negative 4 in for b, and so I divided negative 4 by 2, which is of course negative 2, and negative 2 squared is 4. So then you're going to want to take the term that you get here, so in this equation 4, and add it to both sides. So now on this side I have x squared minus 4x plus 4 equals negative 1/3 plus 4, and I just put the 4 over the 1 to make the next addition of fractions a little bit easier. But that is of course not necessary if you're plugging into your calculator. Okay, so the next thing that you're going to want to do is, well, I added these two fractions, or subtracted 1/3 from 4, and got 11/3. But you see that this equation over here has turned into x minus 2 squared. That is because now that we have these terms and this is the perfect square, you can just take the perfect square or the square root of 4, which is 2, and the square root of x squared, which is x, and then just put square that equation, and then you'll also, to get rid of this, the exponent of 2, you're going to want to take the square root of both sides, canceling, so this of course cancels out with this, and you're left with x minus 2 on the left-hand side, and the square root of 11/3 on the right-hand side. Now, I like to just draw the square root sign over both the 11 and 3 to make the next step that you're going to have to do a little bit clearer, because you have to remember that you can't ever have a radical in the denominator. So to get rid of that radical 3 in the denominator, you're going to multiply the fraction by radical 3 over radical 3. So when you multiply two radicals, the square root sign cancels out, and then you're left with just 3, and 11 times 3 is 33, and you keep the radical sign for that because they don't have the same base number. So you are then left with x minus 2 equals the square root of 33/3. And then you're just going to want to get x all by itself by adding the 2 over to both sides. So you get x equals 2 plus or minus the square root of 33/3 as your final answer. The next problem for the Chapter 4 review deals with an inequality. So The problem that you are given is 2x squared minus 11x plus 5 is greater than 0. So what you're going to want to do is factor or simplify this as much as possible, and you can do this by the quadratic formula, completing the square, or in this problem, factoring was the easiest route to go. So I just multiplied the a term by the c term to get 10, and multiples of 10, as you can see here, that add up to 11 are negative 11, are negative 10 and negative 1. Because when multiplied, that equals positive 10, and when added, that equals negative 11. So then we're going to factor that out by plugging it in. So 2x squared minus 10x plus negative x plus 5 is greater than 0. I can pull a 2x out of this parenthesis to leave x minus 5 in the parenthesis, and I can pull a negative 1 out of this parenthesis and to leave another x minus 5. So that means that I have 2x minus 1, and then I'm just going to set both of these equal to 0. So 2x minus 1 set equal to 0. You're going to add over the 1. And then to get x by itself, you're going to have to divide over the 2. So you'll get x equals 1/2. And then over here, I get x minus 5 equals 0. You're just going to add over the 5, so x equals 5. Now, you're not done yet, because in inequalities you have to check for the intervals. So you're going to set up 3 test intervals that using the 2 zeros that you found. So the first one would be lower than your lowest term, so x is less than 1/2. Your second one would be an and, so you put x in the middle, so x is less than 5, greater than 1/2. And then your third interval, test interval, would be x is greater than 5. So you're just going to want to find a number that is in this interval and plug it into the x in your original equation. And if it does end up being greater than 0, then your equation checks out. But if it ends up not being true, then it is not a true 0, and so it's not part of your solution or an interval for your solution. Okay. So to test this, x is less than 1/2. I chose 0 as a point that is less than 1/2, and I ended up getting, so after doing 2 times 0, which is of course 0, negative 11 times 0, which is of course 0, I'm just left with that positive 5, and positive 5 is greater than 0, so x less than 1/2 is an interval that works and is a solution. Then I checked my x is less than 5, greater than 1/2, and a point that I chose that fits into that interval is 1, so I multiplied, so the square, 1 squared is 1, times 2 is 2, negative 11 times 1 is negative 11, and then just bring down that positive 5, and this, so then 5 plus 2 is 7, 11 minus 7 is 4, and the 11 was negative, so it's a negative 4, is greater than 0, and that is, of course, untrue because negative numbers can never be greater than 0. Then for